For this question, we can use substitution. So we can set u to be equal to the denominator. If we set u to be the denominator, we can easily, after we sub everything in, separate this into individual fractions that can then be individually integrated. So if u is equal to 2x minus 5, then du dx is 2. Rearrange this for dx. dx will then be a half du. And for the numerator, so what we have over here, the 4x plus 1, we can rearrange what we have here, the 2x minus 5, for 2x to start with. So 2x is equal to u plus 5. I'll then times everything by 2 to get 4x. And then I can add 1 to both sides. So now we have exactly what we're going to be replacing the numerator with. 4x plus 1 is going to become this. So these are the three things we are substituting in. So let's do that now. The integral then becomes, so the numerator becomes 2u plus 11, denominator becomes u, and the dx has become a half du. Multiply this out, so numerator stays as is, denominator becomes 2u because of the 2 and the u that we have here. And then we can split this up into two fractions. So 2u over 2u plus 11 over 2u, which is 1 plus, I'll write this as 11 over 2 times 1 over u. Just so it's clear, for our next step, so the 1 integrates to make u, this term that we have here, the 11 over 2 times 1 over u, 1 over u integrates to make ln u. The 11 over 12 is just multiplied by it, so that constant just carries through. So the integral of 1 over u is just ln u, and the 11 over 2 is just put in front. Now replace the u back with 2x minus 5, so this then becomes 2x minus 5 plus 11 over 2 ln 2x minus 5. And then we can, if we wanted to, we don't have to do this, we could absorb the minus 5 here in the constant. So we can say that this is equal to 2x plus 11 over 2 ln 2x minus 5 plus some new constant c prime. So another way in which we can integrate this, so when you get good at integration, this method is a more efficient way in which you can do this integral. So I'll just rewrite the integral here, 4x plus 1 over 2x minus 5. You can rewrite the 4x plus 1 as, so 2 lots of 2x minus 5 would be 4x minus 10. To get the plus 1 on the top, we can add 11, and now the minus 10 plus 11 is just plus 1. So our numerator hasn't actually changed. It's the exact same thing numerically. It's just written in a different way. Now we can separate this into 4x minus 10 over 2x minus 5 plus 11 over 2x minus 5. The first term, this one here, that is just 2. The numerator is 2 times bigger than the denominator. So this is then the integral of 2 plus 11 over 2x minus 5. 2 integrates to make 2x, and this term here will integrate to make 11 over 2 ln of 2x minus 5. If you were to differentiate ln of 2x minus 5, you will get 1 over 2x minus 5, but then a factor of this 2 will come out as well. And that's just when you use the chain rule, that's what happens. You have to differentiate the inside as well. A factor of 2 comes out when we differentiate, hence why we have the divide by 2 here to cancel out with this 2 when it comes out. And that would mean that this would differentiate to make this exactly. And it's the same thing. This is the same thing as what we have here. So there are two ways in which you can integrate 4x plus 1 over 2x minus 5.